Hello everyone. Today inshallah we will start our Calculus II course. I'm really very happy to be with you today. Inshallah we will continue on the composite functions. This is going to be our first lecture, but before we are going to go through composite functions, I would like to give you some information about our course for this semester. Of course, our course notes references, you will find them all on Moodle. Also, the recorded lectures, you will find them. I think I've opened a playlist for Calculus 2, for SVE. I don't remember the theme. If it is tobacco or something, you will find something like this. I will go through it with you later, inshallah. For the time being, and with the first lecture that we are going to have, as I told you, we will have some information I would like to go with you. First of all, Moodle platform is a wonderful and very strong, one of the strength points actually for SVE. You should be familiar with it. You should go through Moodle and go through the various icons that exist in Moodle. You will have a lot of information regarding the course, regarding the assessment method, and everything. Also, you will find videos recorded from lesson. That's if you need to review anything or to just to go through it, so it will make your life easier. Those are the main slides, a little bit different than the slides that we will share together. So probably I will send you both slides on our WhatsApp, but on Moodle you will find only the slides from lesson in order to avoid any confliction between the two resources. You will have exercises, forms, midterm tests, previous midterms and results, and tests, and also you will have questionnaire about your feedback about the course, and so as I told you, it's really very essential to go to Moodle in all times. Our course in Calculus 2 can be divided to two parts either. The first part is about theorems, and the second part is talking about optimization in specific. For the very first part, we will have just an overview about the derivatives and how to do them. Then we will start with order theorem, mean value theorem, Taylor theorem, inverse functions theorem, and the implicit function theorem in fields. Also, we will go through the second part, and this is going to be after the first midterm. We will go through optimization, the basic concepts of optimization, unconstrained optimization, optimization with equality constraints, and optimization with inequality constraints. The assessments is really very direct for the normal setting. You will have 2 tests and 1 final exam. All of them will be running through Moodle. So the first 2 midterms, midterm 1 and midterm 2, this is 25%, and then you will have a 50% for the final exam, and that's the represent the whole marks as you can see. For the highest grade between these with the continuous assessments or with a final 100% on the final exam, we will see what's the best for you. Also, the negative point about this assessment for you is you will have to get greater than 8.5 in the final exam to be considered. So even though if you got good grades in test 1 and test 2, still you will have to get 8.5 at the final exam at least. So this is really very important. The result will be exactly the same as I told you, either the continuous for correcting 1 or 2 of these exams, or taking just only 100% on the final exam, regardless of your grades with the tests through our course. Also, there is a grade improvement, and it will be applied according to the university regulations with continuous assessment or with 100% for the final exam. For the calendar of the exams, those are the announced times for the tests and midterms relative to Lisbon. we have succeeded in giving you just or changing most of these times in order to be able to have it directly. The first was respect to our time and schedule in Cairo campus, and also according to the events. You know, the second semester we have Ramadan, we have the feasts, and so on. So the first midterm will be running Monday, 9th of March, and it will start from 11 a.m. and it will run for 130 minutes. It will be on Moodle. The second midterm is going to be on 27th of April. I think it is exactly the same like Lisbon. The first one we changed it, but we are not going to have it at 5:30. I will do it at 10 a.m. or at 11 a.m. inshallah. For the final exam, instead of having it on the 27th, we succeeded to have it on Monday 25th, because 27th is going to be the first day of Eid al-Adha. Okay, so we are not really sure, and I've tried to avoid 26 also, because you know, before the Eid, maybe people are not going to be available or so. And the final exam will be running for 2 hours. Hopefully, we will not need the second entry, which is going to be the 22nd of June, inshallah. Okay, very good. Now, for the study plan, we will have to review chapter 0. Chapter 0, this is really very important. It's apart from Calculus 1. As you know, it contains the principal rules of derivative. We will go through them. I can give you also a PDF containing the general notes about derivative and anti-derivative integration. Both of them will be needed. Also expect that you may find some of these questions about derivative, not the derivative by itself, but you will need it, as you will see down the road. So you will have, it's a very good advice just to review these 2 chapters. I believe in the slides you will find on Moodle the slides of Calculus 1 regarding this part, and also I can share it with you on the WhatsApp. This is our updated study plan that we will try to stick to it in order not to be behind Lisbon as much as possible. So if you remark, we will start this week by the 2nd of February. We are in this week. So we need to cover the presentation, we already did, and starting the part of composite functions from 1.1. Hopefully we will be able to cut as much as possible in it. Next week, inshallah, I will be working with the continuing the same slides, inshallah, for the composite function and for homogeneity. Hopefully we will be able to do this within next week. It's a very good advantage that we have our work on Wednesday, just only on Wednesday, and also it has a negative side, because you will remain almost a week without seeing me or following up with me. As soon as my schedules or tables settle down with respect to FCT and the IMS, I will try to find if there is an open slot or something for me, and it is free for you just to have it as a backup, as I told you before we start our lecture. Okay. Do you remember the partial derivatives? What do you mean about partial derivatives? Partial derivatives, it's one of the required, or it is the only way in order to get a derivative of a function in more than one variable. So if I have a function in multi-variables, or more than one variable, the only way to get derivatives is to use partial derivatives. The rule is really very simple. You will find it is summarized in this graph. So partial derivatives show how a function changes as we vary one variable while keeping the other variables is fixed. This is the symbolization of the function f derivative, either with respect to x or with respect to y. We will be able to choose this. So, as I told you, the main issue is to review, as I told you, the main concepts of derivative and to try to organize them in your mind. For example, in order to refresh this, we will have plenty of practice problems within the first lecture, inshallah. Okay, so as you can see, if I want to get the derivative of the function f, let's say f is given by x squared y plus 3x and y squared and plus 4y. According to your knowledge in linear algebra, if you remark this function, it's actually modeling, okay, or making a transform from R2 into R. This is two-dimensional, which is x and y, and will appear to you in R. So actually the domain is R2, and the range, okay, will be in R just only. So, Mr. Adam, if I want to get partial f, partial x, what to do? I will differentiate this function with respect to x, considering the other variable, which is y, as a constant. So, simply, Adam, partial f, partial x can be easily written as the following. Start differentiating the first, which is x squared times y. I will start differentiating x squared, which is gonna be a 2 of an x times y. Y appeared here because it's a constant, it's like a number. And if I try to continue and to hit the second part, which is simply 3x times y squared, can you tell me what the derivative? 3 y squared. Y squared. Yes, exactly right. So it's going to be a 3 of a y squared. For 4y, the derivative will be 0. Okay, perfect. That's the first derivative with respect to x. In a similar manner, if I want to get the first derivative with respect to y, it's going to be the opposite. I will make y in the main variables and x is a constant. So let's do it together. Partial f, partial y is going to be differentiating this part, so it will be x squared. And then differentiating this guy is gonna be
2y.
2 times 3, which is gonna be 6x y. Am I right? Plus just only 4. Yeah, this is the derivative with respect to y. Of course, we can get the second derivative. For this problem, if I want to get the second derivative with respect to x, it's really very easy. So this is the second derivative with respect to x, but in this case, I can get partial 2f partial x squared, which means I will differentiate this function 2 times. The second time will be also with respect to x. So I will differentiate this guy with respect to x. So differentiating the first term will leave you with just only 2 of a y plus 0, because 3y squared doesn't contain any x. And also I can get very easily partial 2 of an f partial y squared, which means I will differentiate 2 times with respect to y. So if we try to do this, you will end up having, this is 0, because this term doesn't contain any y functions. And also for the last part, it's going to be 0. For 6xy, the derivative will be simply 6 of an x. Also, if I want to get partial 2f, okay, partial x, partial y, it means I will do the next partial derivative, which means I will differentiate the function the first time with respect to x, while the second time will be with respect to y. So all I have to do is to get the first derivative, which is respect to x, then I will differentiate it with respect to y. So let's start differentiating with respect to y. The first term will give you a 2 over x. The second term will be 6y. That's for getting this the second derivative, the mixed second derivative. The first was respect to x and the second was respect to y. In a similar manner, if I want to get partial 2f, partial y, partial x, which means I will get the second derivative of the function y, but with respect to x. So that's the first derivative with respect to y. Let's differentiate it with respect to x. So if we try to do so, x squared is going to give just developing a 2 over x. And for the second guy, differentiating with respect to x will develop 6y. And as you can see, they are both equal to each other for the mixed derivative. if you get the first derivative with respect to x and then the second with respect to y, or vice versa, it's going to be the same as you can see. So this is really very important and need training. So after I send you these slides, please try to resolve all of these problems, even the trivial ones, by your hand, exactly as I'm doing. This is gonna shape and give you more trust in yourself in using pens and so on. So it's exactly the same, differentiating f with respect to x for the section for x squared y and for 3 of an xy. So you will end up having 2xy plus 3y squared exactly as we did. If I want to get partial f, partial y, so I will make a first derivative for this function. So it will be exactly x squared plus 6xy plus 4 as you can see. That's the partial for the partial derivatives of this function, which is x squared. If I want to continue, as you can see, I can get the second derivatives with respect to x, with respect to y, and for the derivative of the function for the mixed derivative as we did exactly. That's the second derivative of an x, and that's the second derivative of y. And also for the mixed derivative, it's 2x plus 6y, exactly as we did. Okay, he wants you here to compute partial f partial x and partial f partial y for the function which is given by e to the power of x times sine of y plus ln 1 plus x squared y. As I told you, you will have to review the various types of functions in order to be able to evaluate what's gonna happen down the road. So as you can see in this example, you have trigonometric functions, you have an exponential, and also you have a logarithmic function. So let's try to get the first derivatives and then the first partial derivatives and the remaining of these derivatives for the second and the next ones. So if I want to get partial, okay, once more, partial f, partial of x, simply all I have to do is to differentiate this function with respect to x. So I would have sine y times e to the power of x, and for the second part I will have to differentiate with respect to x. So I'm stuck. Okay, if you remark, I've only here differentiated the exponential part because sine y is a constant. But for the second part, which contains the ln of the function 1 plus x squared 9, I will have to differentiate first the ln function. Then I will differentiate the argument of the ln function, as you know. So it's going to be a plus 1 divided by 1 plus x squared times 1. Then differentiate with respect to x the argument, which is going to be
2x.
Okay, 2 of an xy. Exactly right. Also, if I want to get partial f, partial y, it's going to be exactly the same, but it will give cosine of a y times e to the power of x. Then plus the derivative of the ln is going to be 1 divided by 1 plus x squared y. Then I will differentiate with respect to y. So derivative with respect to y will give you just, or will develop just only x squared. What if we want to get the second derivative with respect to x? Let's do it together. So getting partial 2f partial derivative of x squared is gonna be, I will differentiate once more this function. So the only one, or the only part that's gonna affect, or it's gonna be differentiated is e to the power of x. So it's gonna come up to a sine of a y times e power x. Plus, can you remember how to differentiate this two functions? The law is really very important. Okay? The law is very simple. If I have y equal u over v two functions, then y dash is gonna be, okay, get the denominator to the power of 2, so square your denominators, okay? Then differentiate the denominator, so I'm sorry, this is v to the power of 2. I will differentiate my denominator. which my nominator, I'm sorry. So it's going to be u dash times v minus v dash times u. So once more, if you have two functions divided on each other, start by squaring u denominator, then go to the denominator, differentiate the denominator times the denominator, then minus vice versa. Okay, let's do it together. So I will start by squaring the denominator, or you will have your denominator to the power of 2. 1 plus x squared times 1. Then I will start differentiating the denominator. I'm differentiating with respect to x. So I will have 2 over y times the denominator, which is simply, the denominator is 1 plus x squared times y. Then minus differentiating our denominator with respect to x, which is going to develop 2x times y. But don't forget, this value is going to be multiplied by the old denominator, which is 2 over x squared. Now I can simplify it if I want this relation. So simply it can be rewritten as e to the power of x times sine y or whatever, then plus the denominator is to the power of 2, which is 1, plus y to the power of x squared. If I try to expand the denominator, which is going to be a 2 over y plus 2 over an x squared y squared minus 4 over an x squared y squared, as you can see. So now I can put it as 2y minus 2 over an x squared y squared, and I can take also y as a common if I like to, or whatever. Like, what if I want to get the next derivative, which is partial 2f, partial x, partial y. So all I have to do, I will depend on the sign of the derivative. So if I want to get partial 2f, okay, partial x, partial y, it means the first derivative is with respect to x. I already have it in here. I will do the second derivative, which is going to be with respect to y. So if we try to do so, it's going to be really very simple. Differentiating this guy, and here you need to give enough attention. Where are you and where you want to go? So I will start with the x, and then I will start differentiating with y. So differentiating with y will develop the following. Differentiating sine y will give you cosine y times e to the power of x, which is a constant, plus I will, okay, square the denominator, or having my denominator to the power of 2. So it's going to be 1 plus x squared times y. Then, once more, Mr. Adam, I will start to differentiate with respect to y. Differentiate denominators with respect to y, so it will give you a 2 over x, times the denominator, which is 1 plus x squared times y. Then minus, I will start differentiating the denominator with respect to y, which is going to give you x squared, times the denominator, which is 2xy. So it's very, very simple. It's going to be a cosine over y times e to the power of x, plus start expanding the denominator, which is going to be a 2 over x, plus 2 over x cubed y, so 2x times 1, 2x times x squared. Then you will have negative of 2 over x cubed times y, as you can see. So these two guys will cancel each other, and it is divided by 1 plus x squared y to the power of 2. As I told you, it's really major to try to work out your hand. It will gather the information about the multiplication case, about the division, about each function, as you can see. Once more, if I want to see the derivative of all of these functions, it's handable. I can do it really very easily. Okay, just a second. So once more, here is ex sine y plus 2 of an xy over 1 x squared y. I've differentiated the exponential part, and for the logarithmic part, this is the derivative. For differentiating with respect to y, this is just only the part that's going to be differentiated. And we have then 1 plus x squared y, which is going to be 1 over this value, times the derivative of the argument, which is going to develop x squared. In a similar manner, if I want to get the second derivative of x, the second derivative with respect to y, or the mixed derivative, all of them are really very easy to do. So it means I will take the first derivative and differentiate it again. Here we go. That's the derivative of each part. This is the first part, and that's the second part. Just simplifying it, you will end up having ex sine y plus 2y times 1 minus x squared y. Of course, I can take some common parts or just leave it as it is. As you can see, Adam, for f of y, it means I will differentiate the function with respect to y. I will differentiate it once more with respect to y. The first part with respect to y, okay, is ex cosine y, which is going to give you with negative ex sine y. The second part, it will work again the same way like I will square the denominator, having the denominator to the power of 2, and then differentiating the denominator, as you can see, with respect to y, and then trying to simplify it. That's the final form. Also, in a similar manner, to get f of x sub y, or differentiating f 2 times, I will have to do it this way. F of x or y, it means I will get the derivative with respect to x, then I will differentiate it with respect to y in a exact similar manner. As you can see, the only result just only 2x, because the other two elements cancel each other. Okay. Now, also you have another couple of problems. Okay. Here's in order just to test your information once more. If I want to differentiate root of x squared plus y squared, do you know how to differentiate with respect to x? It's really very simple. Adam, are you following up with me? Okay. I want you to keep in mind the following.
U times v plus the derivative u
Okay.
v plus v
Times u. This is going to happen if you have two functions multiplied in each other. Just a quick start up for you, but don't you ever forget this. If I have y, which is equal to, I will write it as lows for you. For y equal to x to the power of n, of course, as you know, y dash is going to be n times x to the power of n minus 1. If I have y equal to the power of x, which is an exponential function, the derivative will be, if I have e to the power of f of x, the derivative will be y dash, which is going to be e to the power of f of x times f dash of x. If I have y equal to a sine of an f of x, the derivative, which what I'm writing sine, but actually I'm writing all the trigonometric functions like sine, cosine, tan, it's going to go exactly the same. I will differentiate first the trigonometric function, so y dash will be differentiating sine, it's going to be cosine. For the function, or for the argument f x, times the derivative of the angle inside, or the argument of this function. Also, if I have y equal to len over f of x, معايا Mr. Adam? Y dash is going to be 1 over f of x times f dash x. And usually we write it f dash of x divided by f of x. بص ده لو انا عندي لين بتاع f of x. f of x goes down, بعدين get the derivative of f of x is going to be of the denominator. ماشي؟ طيب برضه واحدة من الحاجات اللي أنا دايماً بحتاجها قوي، لو أنا عندي y equal to بص كده f of x بس to the power of n، okay, which is like this guy، okay. طيب إزاي بعمل الديريفاتيف؟ بص يا آدم، derivative بتاعه سهل قوي يعني y dash will equal to move the ball exactly like x to the power of n. So it's gonna be n times f of x to the power of n minus 1. And don't forget, times the derivative of the argument. So I will multiply by the derivative of f of x. So it's gonna be f dash x. So if I have f of x raised to a certain power, if I have f of x raised to a certain power, I will do how many steps? 3 steps. I will get the power first, then subtracting 1 from the power, times the derivative of what's inside this bracket. So it's gonna be n times f of x to the power of n minus 1 times f dash x. Look at them carefully. Okay, now let's do our derivative. First of all, it's really worth it to put this function f of an x and y equal to x to the power of 2 plus y to the power of 2, and the power is gonna be 1 over 2. Because you know that fractions in the power are roots. Now, let's start differentiating. So either I will differentiate this function on this rule. So let's do it together. The first step, getting f dash of an x and y. I will start differentiating. So the power will go down, which is gonna be half, times x to the power of 2, plus y to the power of 2. And then the power, subtract 1 from the power. So it's gonna be negative 1 over 2. Then times the derivative of what's inside. So I will differentiate this function with respect to x, because I need the partial derivatives. It's exactly the same. So it's not f dash, it's partial f of x and y, partial x. Now I will have to differentiate the x part only. So it's gonna develop a 2 over x. Are you with me? Of course, if the power is negative, that means that power is in the denominator. So actually, I can rewrite this guy is equal to 1 over 2 times the root of an x squared plus y squared, and the denominator will have 2 over x. This is partial f, partial x. Are you with me, Adam? Okay? In a similar manner, I can differentiate with respect to y. You will have a similar function like this one, but instead of having 2x, it's gonna be a 2 over y. معايا؟ اوكي. انا حاسس انك بتهز دماغك، والله خايف انك تكون بتهز دماغك وبس. اوكي؟ دول تمام؟ طبعا it is recorded, so it will be simple for you just to review it down there. Once more, getting the first derivative is going to be 1 over the 2 root of x squared times 2 over x. 2 will eat 2, so that's the first derivative with respect to x. That's the first derivative with respect to y. So if I want to get f double x, f double y, f of x, y, it means simply I will have to differentiate this function once more with respect to x. That function is once more with respect to y, or getting the derivative of with respect to y, but for the first derivative with respect to x in order to get the next derivatives. I will leave this for you just to try it in home and try to get the results of this function. Now, I want you to remember in Calculus 1 a very important definition. This definition, it is about the gradient vector. What's the gradient vector? The gradient vector governs if you are working with a function in or n. Please try to either to close your cell phone or just put it upside down. Okay, I want you to concentrate. Let's say that f is such that it's a function with a domain D, which is a subset from Rn. Do you know what's that mean? That f contains x1, x2, x3, up to xn. So if actually is a function in more than one variable. Are you with me, Adam? It's really very important to feel and to be able to read what's given. So now once more, let f is a function such that its domain a subset from R to the power of n. So I'm expecting that f contains parts of x, y, z, l, m, whatever. Okay, continue. And the a, since it belongs to R to the power of n, so a will be a1, a2 up to an because it contains, it's like R2. You will have x and y. So the points will have 3, 5, 2 and 4, -1 and 0. You read me? If I have an R3, so I will have how many components? 3, it's like x, y, and z. So the points supposed to have 3 coordinates, like -1, 2, and 3, for example. Okay, makes sense. بيقول into D, the gradient vector of f at a point, I can get it really very simple. The symbolization of the gradient vector, it is the upside triangle that you will see. So it means the gradient vector of f of n, which means I will get the partial derivatives of f with respect to its variables. I will get the partial derivatives of f with respect to its variables, which means I will differentiate f. If f is in x, y, and z, I will differentiate with respect to x, with respect to y, with respect to z. طيب, if f is a function in x and y, I'll get partial f, partial x, partial f, partial y. طب, if f is function in x, y, z, and t, then you will differentiate how many times? 4 times with respect to x. This is what's written in front of you, as you can see. Okay, for an example, can you get the gradient vector for this function? At the point 1, 1, 1, let's do it together. Okay, so this function from R3, so it contains how many variables? 3 variables. Remark, it's a transformation from R3 into R.